Let's take a look at problem 11 in your book. It's on page 930. We'll use this as an example of acceptance sampling. The idea of acceptance sampling is that when a shipment of something comes to us and we want to see that it meets our quality criteria, instead of testing every item in the shipment, we'll call it a lot. Instead of accepting every item or inspecting every item in the lot, we're going to inspect a sample. So in this particular case, in problem 11, it says that the sample we're going to take is 20. So we have a shipment comes in, there's thousands of these things, whatever they are, on a truck, and we're going to pick 20 of them at random, and we're going to take a look at them, and each item is either going to pass or fail our inspection. So this problem says that the sample size is 20 and the number that we'll accept, the number of defects that we'll accept, is 0. So we've got thousands of these things on a truck, and they come in, and we take a random sample of 20, which means that we don't just take 20 off the back of the truck, that we randomly take 20, and we inspect them, and if we find one defect in the 20, then we're going to reject the lot. We're going to reject the whole shipment and send it back. Okay, so because we're taking a sample of the population, there are risks involved. So the producer's risk is the risk of rejecting a good lot. So we just happen to get a bad one, but the shipment is really good. So that's the producer's risk. What if the consumer rejects the lot based on one defect, even though the entire lot is really good? The consumer's risk is the opposite. It's the risk of accepting a bad lot. So I didn't find any defects in the sample, so I accept it, but actually there's like 20% of them are bad. But I just didn't happen to pick a bad one. That's the consumer's risk. So it's a statistical risk based on the sampling. Okay, so what I've done here is I've made this is the sample size 20. This is, what if so this is kind of a what if game. So what if the defects in the entire shipment were 0, 1%, 2%, 3%, 4%, 5%, and I found a defect in my sample. So what's the producer's risk that the entire lot will be rejected because we found one bad one? And what's the consumer's risk that will accept a bad lot even though we didn't find a bad one? Okay, that's the idea. Now, your book, as always, gives you a lot of big formulas, but Excel makes it super easy. We'll just use a binomial distribution. It's binomial because it's good or bad. Okay, so binomial distribution, and Excel has a function. It's called equals binomial dot distribution. Okay, and it tells us what we need. So in this case, the numbers, the first criteria in the function is the number of defects we'll accept, and that's 0. Okay, right, in your example, that's C equals 0. That's the number that we'll accept. The trials is the sample size, which is 20. Okay. The probability is the percentage of defects that are actually in the lot, and in this case that would be B5. Okay, and cumulative, just true or 1 is what we want. Okay, all right. Now, what this means is I take a sample of 20. There are actually 0 defects. There's not a single defect in the whole truckload, in the whole lot. But on our sample of 20, we actually find one. Okay, so in that case, what's the probability that a lot will be rejected, even though it's a good lot? Well, it's 100%. Okay, and the consumer's risk would be zero. Would be equals one minus this. Okay, now I can just copy these down. And the problem wants to know what's the producer's risk if the defect rate is 2%. Okay, so this one. And what's the producer's risk if the defect rate is actually 6%? Okay, so I take a sample of 20. Okay, there's actually 2% of the items in the truck are defective, and I find one defect. Okay, what's the producer's risk with rejecting a good lot if I find one? So it's 66%, and the consumer's risk is 33%. If I don't find one, what's the risk of accepting a bad lot? Okay, and if the actual defects in a lot are 6%, and I find one, okay, what's the risk that it will be rejected, uh, even though it's a good lot, is 29%, and the consumer's risk is 71%. This is a statistical risk, and that's what acceptance sampling is. It's widely used, and what will happen is the producer and the consumer will agree on an acceptance sampling outcome that they can both live with, and that's how it's computed.